Hi, I'm Katie Brigden. I'm here in Lerwick in the Shetland Islands, home to some of the Scottish pelagic fishing vessels. I work with the Scottish Pelagic fleet on an industry self-sampling project where the vessel crews have volunteered to collect data as part of their normal fishing operations when they're out fishing for herring, mackerel and blue whiting. In 2018 we set up a pilot self-sampling programme with 6 of the 21 Scottish pelagic vessels. Since then we've tested and developed the data collection methods and recruited more vessels, so that now in 2021 we have an established self-sampling programme collecting quality data, and we have a commitment from the full fleet to a long-term data collection programme. So come with me, we'll step on board one of the vessels and I'll tell you a little bit more. So this is a sampling room on board one of the fishing vessels. This is where the vessel crew come to measure their fish for length and weight. As part of the programme we give the vessel crew training on how to measure the fish. We also provide them with all the necessary kit, so that includes a measuring board, sampling protocols, also the recording sheets for the data collection. And as part of the programme we also developed an electronic keypad. The keypad links up to the scales and pairs the length and weight measurements for each fish, and allows for more efficient paperless data entry and standardised recording. And more recently we also added frozen sample collection to the programme, so vessel crews will collect a sample of fish, freeze it on board and then bring it back to scientists in the local laboratories. And when it's worked up we get extra information including the sex, maturity, and we take out the ear bones for ageing as well. And the length and weight data that's collected is taken from every single haul that's carried out, and the frozen sample collection is for selected random hauls. The crews will also collect all information so that we can link up all of that biological information to where the fish are caught and when they're caught. As part of the pilot programme, we also tested, evaluated and revised the methods used as well. So this included making sure that they were feasible and practical to work on board fishing vessels as part of normal fishing operations, and also making sure that we could evaluate them against the published guidelines on best practice. And this made sure that we had methods that we could use that were robust and reliable for data collection. We also examined the quality of the self-sampling data by comparing it against the Marine Scotland factory sampling data, which is what's currently used in stock assessment. These comparisons give us an indication that the methods used are robust and that also the data being collected are of good quality. So let's take a look at the comparisons now. The maps show the number of sample trips per ICES rectangle for the winter mackerel fishery, which takes place in January-February. The trips which were factory sampled by Marine Scotland are shown on the left, and the trips which were self-sampled by vessels are on the right. We can see that the location of trips sampled as part of the self-sampling programme overlap directly with those trips sampled from factories, but the self-sampled trips also have a wider distribution beyond the factory sampled trip locations. The self-sampling data can also be further resolved with individual haul locations and include samples from vessels that land in other countries which would be missed by the factory sampling. These plots are again for the winter mackerel fishery. Here we have length distributions for both the Marine Scotland factory sampling data, the pink line, and for the vessel self-sampling data, the blue line. Each of the 6 individual plots is for a specific fishing trip, where data were available from the 2 datasets. This enabled the 2 datasets to be examined at closer resolution, comparing the fish length distributions from the same time and place. We can see that the length distributions between the 2 datasets demonstrated a close overlap, indicative that the self-sampling is achieving the same data collection as the factory sampling. And the self-sampling programme is able to collect this data from every trip that's carried out by all the vessels involved. Looking again at the winter mackerel data, the plot shows the length-weight relationship from the Marine Scotland data, the pink line, and for the vessel self-sampling data, the blue line. The difference in the 2 datasets here is that the self-sampling undertakes collection of weight data in addition to length, while Marine Scotland factory sampling undertakes only length sampling from which a predicted weight is calculated using designated parameters. So when we compare the 2 length-weight relationships, mean weight at length for self-sampling data and predicted weight at length for Marine Scotland data, we can see that the observed self-sampling weight data indicate that fish of intermediate lengths are achieving greater weight at length than the predicted weight. Sampling both lengths and weights provides fundamental information on fish growth and enables seasonal and interannual variations in growth patterns to be captured. It also provides valuable data for research on species ecology.
So that was just an example of some of the comparisons from the winter mackerel fishery data. An analysis such as that is really useful in demonstrating the data value and the data quality, and also in allowing us to assess the utility and the application of the self-sampling data. And what the comparison showed us is that self-sampling data is capable not only of collecting data that's comparable to the current factory sampling data collection scheme, but also it can add information on top of that. For example, the finer resolution of information at the hull level, and also the observed weight data. And in addition to the collection of valuable data which can inform fisheries science and management, the programme has also enabled a successful collaboration between science and industry. So going forward from this point on, with an established and proven self-sampling programme, the intention is to submit the data to ICES for use in stock assessment. In order to do this, we need a 5-year time series, of which we currently have 1. So the focus now will be on ensuring the continuity of the programme so that we can deliver that time series. More widely, the establishment of the self-sampling programme has taken place at a time when there's a growing momentum for co-management in the UK, in Europe and internationally, with opportunities developing for industry to contribute to fisheries science and management. For the pelagic self-sampling data to be used, it will need to be accepted by ICES, who have committed to facilitate the use of industry data. That's meant that as part of the programme as well, we've been engaging with ICES in order to demonstrate the data that's available and also consider how to go forward with incorporating that into stock assessment. There is also further opportunity to contribute to and improve the regional catch sampling of widely distributed pelagic stocks, with international collaboration on different country organisations in developing catch sampling design. So that's been a whistle-stop tour of the Scottish Pelagic Industries self-sampling programme. I hope it's been informative. If you have any questions, please get in touch. Thanks very much.